All right, I'm going to go ahead and get started. Welcome, everybody. Very excited to bring to you our next in the series of webinars on the MITRE attack deep dives. As you can see here, we're going to be talking about persistence, and we got a lot of great folks who are in the attendee list here today. I see we've got folks from all over the world, which is always a blast. So, good morning, good evening, good afternoon, whatever time of day it might be for you. We're glad you can join us, and we're going to go ahead and get started. First of all, by way of introductions, I'd like to go ahead and introduce our panelists. I'll have each of them give you just a little bit of their background, and we'll start right off with you, Shane. Welcome, and give us a little bit of your background.
Hey, my name's Shane Welcher. I'm a detection engineer over here at Red Canary. I'm based out of Dallas-Fort Worth. I kind of have a background more focused towards system administration before I came into security. So I kind of got a good idea of how all this stuff goes together pretty well. So.
Great, glad to have you here. Blake, welcome. Blake's one of the co-leads on the attack plan, the attack lead, and one of the co-creators. Give us a little bit of your experience there.
Thanks. I've been at MITRE for almost 7 years now. Created attack, working in adversary emulation. Also on the team that created the attack product evaluations effort, and in a bunch of other research projects like the Caldera automated adversary emulation system.
Cool, awesome. We got the source right here with us for the presentation, so we're glad to have you. Welcome. And last but not least, Greg.
Hey everyone, my name is Greg Foss. I'm a principal threat researcher with Carbon Black. My background's primarily ethical hacking, penetration testing, and those kind of fun things. Here at Carbon Black, I focus on security efficacy and the generation of all of the rules and queries that you see within the Carbon Black product line.
Very good. Awesome group. We've had a lot of fun putting this material together for you. My name is Phil Hagan. I'm with Red Canary as our DFIR strategist, and I also am a senior instructor with the SANS Institute, where I'm the lead for the network forensic class. So you've got with you today for the next hour, and without any further ado, the #1 question that we always get is, will this be recorded? So we want to make it very clear. Yes, absolutely. You're going to get an email about a day or two after the end of the webinar. It's going to include some bonus content, which we're going to discuss a little bit more, as well as a link to the recording and some other content we're going to be discussing. So you will absolutely have a chance to do that. Other housekeeping item for you. You'll see that you have a question and answer feature in your Zoom interface. Feel free to drop questions in there whenever you happen to think of them. We will either have some of our other team who is waiting in the wings, if you will, answering those directly to you, or we will bring those to our panelists either during the presentation or at the end. And we will have about 15 minutes as our plan for Q&A at the very end there. And we'll make sure that that is all situated. And there is the first question: will it be recorded? Very, very well played. Thank you, Jorge. Of course, the answer on the screen. 3 points to you, sir. Here's what we're going to cover today. We're going to give just a little bit of overview on what persistence is. I'll do that real quick. We're going to give you some examples of what types of persistence an adversary might use, and more importantly, why they want to use them. Why is this a thing that we care about anyway? We got some examples, we got a demonstration for you, and then of course we'll have that Q&A toward the end. So the overview of what persistence is, let's go ahead and just go straight to the source, straight to the formal definition here. We're going to pull that straight out of MITRE attack. You can read this up here, but realistically, let's boil it down to its core essence. Persistence is an adversary's means of maintaining presence and access to a compromised asset. It's going to be some way that they can come back to that system days, weeks, months, potentially years, although hopefully not. And it's going to give them the ability to get back to that asset or that compromised system. Of course, they put a lot of investment into gaining access in the first place. They don't want to lose it. It's kind of an economic decision for them. Now, in terms of why this is such a big deal, I'm sure that you've got a pretty good idea of that, but let me go ahead and hand this off to Blake for a moment. Give us a little bit of more in-depth understanding on why this is such a big deal for adversaries.
Great, thanks, Phil. So the reasons that adversaries can persist are roughly organized into 2 areas. So needing their tools to be able to run through intermittent interruptions, and also needing to regain access after being discovered and removed from the network. So to tackle the first one, it often takes time for an adversary to reach an objective. So that puts them at the mercy of things like users turning off systems, patches, reboots, tools crashing, So an adversary really needs mechanisms in place so that their tools can restart and they can connect back in those sorts of situations. So they really need that resilient type of access. They're also thinking about the problem in terms of operational redundancy. So they'll want to have multiple different tools with different persistent mechanisms deployed. So that's in case of AV signatures being updated, and maybe they lose part of their infrastructure and they have that backup that wouldn't be affected, or maybe defenders discover one but not the other, and they can't piece it together to find the rest of the activity. So that sort of leads into the second point. So adversaries are also looking to persist through the full IR process, so being discovered and remediated. So they'll want other mechanisms in place to reestablish access, and that could be things like Webshells or use of valid accounts with stolen credentials that they've gathered that allows them to log into remote services. So also, depending on what their goal is, they might set up stealthy forms of access and data collection that might persist if other mechanisms are found. So one really good example that's recent is ESET's light neuron report, which Turla had used exchange mail transport agents on the server, which allowed them to send commands in through email to maintain that access and collection.
So it sounds like there's quite a lot of those. And obviously this is a bit of an eye chart. I'll go ahead and ask straight out, like, how many different individual techniques are there under this tactic?
There are 59 techniques currently documented in ATT&CK. Now keep in mind, this isn't really an enumeration of all possible techniques. There's other theoretical things out there that we don't know that adversaries use. So it's important to note that ATT&CK really focuses on what's reportedly used out in the wild. And some of the techniques can be broad in scope, some are very narrow, but it is a very useful way to describe the ways that adversaries persist that's known.
So somewhere between 59 and infinity, let's say.
Yeah, more or less.
And I think you guys are doing some work on refining that down a little bit further. Give us a little bit of background on what you're doing with these sub-techniques, because that might be a new concept for some of the folks in the audience today. Yeah,
sure. So sub-techniques is a concept that we're working on right now. So the ATT&CK team realizes that there are a lot of techniques out there, so we need a better way of organizing them. So some of the techniques are very broad in scope, some are very narrow. And as we keep doing updates, the matrix keeps looking less and less like an actual matrix. So we're hoping that sub-techniques and some other changes we have planned will make ATT&CK easier to use longer term and more sustainable as it grows. Sub-techniques, it's basically a reorganization of the current techniques to even out that abstraction across them. And what that means for persistence specifically is we created some bucket techniques that help describe the various ways that an adversary would think about implementing a persistence mechanism. So a couple of those examples are on the right there. So that could be loading code before the OS loads, which might bypass some security features in the operating system. It could be loading through initialization scripts or when the system starts, or even event-triggered execution like accessibility features on Windows. So these changes aren't live right now. We did release a blog post a few weeks ago to describe these in more detail, and we're looking for feedback on that. But we're looking to push these out in a companion site to ATT&CK sometimes towards the end of the year to give people time to give us even more feedback on the changes and allow them to plan changes in their tools or projects to cut over to sub-techniques.
Brilliant. You know, when I first learned that you were doing the sub-techniques, my first thought went to, of course, not in, as you said, enumerating every single possibility, but I like that this is giving a variety of specific examples that can hopefully say, oh, you know, maybe we're not using bash, but stuff that runs automatically when the shell process starts, you know, whatever shell that might be. Like, it's enough of a close parallel that it's going to give you a good idea for that. So I'm really excited for that to come out. Definitely keeping my eyes open there. Let's take a look now. Shane, I'm going to hand this over to you. Give us an idea of some of the specific types of persistence, especially the stuff that you see in the detection arena.
Yep. As we kind of saw in that little image we saw just a second ago, there's a lot of different techniques. Some of them are a whole lot more complicated to detect than others. The good thing is some of the easier ones are the ones that are used more often, which is kind of weird. You would think the harder, you know, to detect something, people would be trying to use that. But the ones that we see most commonly are typically kind of on this page, and even in further depth, we see most of the time just scheduled tasks, binaries and startup locations, registry run keys, and of course account compromise. Those are kind of the ones that we see more often than not. And so if I was, kind of starting out my detection capabilities within an environment, or if I even have an existing one, those are probably any on these pages are really going to be the ones I'm going to try to focus on to ensure that I have coverage. Because one of the neat things about persistence is a lot of the times we see multiple different forms of persistence deployed at the same time. So if you don't have full coverage across all the different techniques of persistence, one of those easier forms of persistence that we can detect may trigger an investigation into identifying something else that was used in your environment. So it's kind of neat. Persistence is kind of one of those, I guess, techniques that is really easy to detect on, and you can kind of trace everything back of what happened on a box. So we'll kind of touch a little bit more here in a second on some of those ones I mentioned that we see most commonly on how to detect them. But like I said, these, this is just a small subset of the many different forms of persistence.
Sure. So if we even take that down a little bit further and kind of take some of those sub-technique concepts that we talked about a minute ago, Blake, give us a couple examples on some specifics that you've seen. And this is not just a specific method, but like specific examples of where these have been used by capabilities or actors.
Sure. So this really gets into another important part of an attack, and that's linking the threat intel that shows which techniques are in use and how that might relate to people caring about them. So organizations commonly focus on things that groups target them use or target their industry, which helps them prioritize. So to get into some specifics here, Webshells are generally scripts that get deployed to publicly accessible web servers, and that allows adversaries a backup access into the organization. Since nothing's beaconing out, they're not going to see that sort of activity. The traffic's coming into the web server, which is pretty much expected. But in terms of use, we've seen these used by state-sponsored adversaries, and China Chopper is a specific type of web shell that's been used by multiple Chinese groups. And then getting into WMI Event Subscription is another technique that's becoming more popular because it can be a little bit more difficult to detect. And in attack, we've documented use by state-sponsored adversaries, so Russia, China, and Iran, pretty much covering the high ones. So registry run keys is a very common technique used by a lot of groups in software. There's basically a set of things that Windows runs when it starts, and it's really simple registry change to make those work, either when the user logs in or Windows starts. So in total, there's 127 linked group and software examples in attack right now. And this usage pretty much spans the board because it's so easy to use. So state-sponsored activity, financial crime, and even common malware. Valid accounts is another really common one that adversaries can use to access systems and even persist. And it's another reason why it's important to understand the scope of an adversary's access before you start remediation, because those accounts can provide the backup access, because they're often used in conjunction with things like RDP, Citrix, VPNs, and other remote services. But we've seen use by state-sponsored adversaries in financial crime.
Very good. And talk to us a little bit about the frequency with which you see this. I know some of your folks had a talk fairly recently that kind of covered this.
Yep. Katie Nichols, the attack threat intel lead, did a joint presentation with Brian Beyer from Red Canary, where they did some data analysis. So this is just representing the attack end of it. So what we did was we looked at all of the public threat reports that we had currently documented in attack and try to figure out what are the top 20 techniques. So in those, number 6 was registry run keys. And I mentioned earlier that there was 126 or 7 references there. And the one that, the second one that came in at number 20 was a new service, which had 57 references currently.
Well, a question came in. Dow actually asked this one. I thought it was a good place to interject this. Very commonly used, of course, we see those top 2 right there is their rankings. But what about when, during a typical attack, any of these techniques may be seen? Is it usually one of the first things they do? Is it kind of part of their pre-departure activity? Is there any common behavior at all? I open that up to anybody that might have some insight there.
Yeah, I think from my perspective on the attack team, it's really both. So it's really common for malware to establish persistence automatically when they get onto a system and start the initial discovery. But it does happen after the fact. So as adversaries are pivoting around a network, they're also establishing persistence on other points of interest with things like new services.
Got it. All right. Well, given that it's so common, so important, let's also talk a little bit about opportunities to detect. We've got a lot of different ways to see this, and you know, Antonio actually asked a question along these lines as well. So I think we're going to get a chance to jump in there. Hopefully, Greg will be able to jump in. But go ahead and give us an idea of ways we can see this happening in the first place.
So some of these, like I said, are a lot easier to detect on than others. You don't have to deploy Sysmon or PowerShell script block logging if you know your scope of what you're wanting to detect is just your scheduled tasks and service installations. These two types of events can be kind of noisy in your environment, so it does take a little bit of love and care to get that down to what you want to see. I highly recommend this for any organization. It helps you understand not only from a security standpoint, but from a change management standpoint of fully understanding what's going on in your environment. Those two right there alone, you know, as soon as you get some kind of event forwarding in your environment, highly recommend pushing those out. In addition to that, if you don't have a full EDR solution, and even if you do, highly recommend one or the other, Sysmon and PowerShell script block logging. You know, you can do things like monitoring the startup locations or directories with Sysmon, just any kind of binaries that's getting written to that file path. That'll help you identify some malware that just deploys itself into those locations. Same thing with like PowerShell script execution. You know, understanding what's executing in your environment is really important. And some of the EDR platforms, they don't always capture script execution, what's inside a script to begin with. So this is where having this in conjunction with an EDR solution, if you can, really helps kind of give you additional visibility into your environment. So some easy ways to detect things is if we see it quite often, if you don't use encoded PowerShell in your environment, just easily detecting on encoded PowerShell, encoded commands within your environment is a really easy win for you. And you really even don't have to know much of what if you really don't care what's being encoded, just if you're not using it, it makes a really easy IOC, if you will, to detect on. We see it for the most part. It's kind of rare for, I guess, for malware nowadays not to use encoded PowerShell, which is kind of weird because it's something pretty easy to detect on. We see some of the more advanced people kind of shying away from encoded commands now, but it does help you give tremendous visibility into your environment. In addition to that, Sysmon will also log your registry changes, which you can again look for those run keys. And in addition to that, any PowerShell commands that are being stored in your in the registry as well. And like I said, it does take a lot of effort to deploy Sysmon. PowerShell script block logging, not so much, but you got to kind of tune how you detect that in your environment, depending on how you're using your alerting. But highly recommend if you have the money to buy an EDR solution. It is very, you know, it gives you a lot more visibility, and it's a lot easier than having to go correlate things back in some SIM with Sysmon and script block logging. But like I said, if you can, I know it can be CPU intensive on some computers, but if you can afford to put Sysmon in an EDR solution on an endpoint, it's highly recommended. Something we don't really talk about on here too, and Blake kind of mentioned it, the valid accounts. You know, it's very important kind of to understand what's going on in your environment. So doing regular auditing, you know, and making sure those old accounts are getting disabled, and and accounts that you're, just regular audits of your higher privileged security groups in your environment, and as well as on your firewalls and any other piece of network equipment in your environment is super important to do. So highly recommend that as well. And then something we really also don't get too much into, we wrote a blog last week, and it was kind of talking about some of the more advanced techniques we see. So definitely check that out. It kind of covers some of the file integrity monitoring that you'll definitely want to make sure you have deployed on web servers, as well as anywhere where you have high value scripts executing in your environment.
Nice. Definitely a lot of opportunities. And I wanted to real quick touch on the fact that, with the examples that we're going to be going through here, recognizing that we are looking at this in a Windows-centric kind of point of view, there are probably maybe an entire set of information we can talk about in the future about opportunities on macOS. There are parallels. It's not going to be exactly the same, but we wanted to try and keep this webinar close to the example that we're going to be going through. And we'll actually take that as a discussion point to see if we might be able to look a little bit more closely on the macOS side. There is one question on the Windows-centric side that, Greg, I think you were going to talk about briefly. If you can touch on where you think WMI Event Subscriptions are going to end up being detected, what the opportunity for that is.
Yeah, so I'm glad that Antonia actually brought up this question, because we chose the demo that we'll actually go into in a few moments here is actually covering WMI Event Subscription, and we're going to be looking at 7 different ways you can detect that activity. So I don't want to spoil it yet. We'll go ahead and jump in where we can show you some examples of exactly how you can find this behavior.
Awesome. Good foreshadowing. I love it. You needed to do that in a movie announcer voice, I think, but let's jump back into that. Before we do that, though, something we're going to try new. We are going to discuss here what we're going to do next, and we're going to give you a chance to do this. What I'm going to do in just a moment here, I'm going to launch a poll in that Zoom interface, and we're going to list out the tactics that we have not yet covered, either previously or today. And we're very interested in which ones you are interested in, because we want to try to figure out what the next in our series is going to be. I'm going to leave that poll up for the entire webcast. And so once you vote on that, you can close down your window if you'd like. But I want to make sure everybody has an opportunity to do that. So that is launched now. Feel free to give us an idea of what these are. And if you're not familiar with what some of those techniques might be, tactics rather might be, feel free to maybe do just a little bit of quick research in the attack documentation while we're talking here. But I wanted to give you time to do that and let you know what that new window is that's popping up in front of you. But without further ado, I am going to turn this back to Greg, because the demo we have is exactly what Antonio had asked about. What about detecting WMI Event Subscription? So with that, I will turn it to you, Greg, and I'm excited to see the demo.
All right, well, thank you, sir. Let's go ahead and jump right in. So essentially, what we're looking at here, WMI Event Subscription is also known as Technique 1084. It's the reason we decided to cover this in this webinar is because it's something we're seeing more and more commonly leveraged by both malware and just red teams and post-exploitation and gaining that initial persistence in general. And it's one of the ones we've gotten a lot of questions around, how do we actually detect this? Because it is one of the trickier kind of persistence mechanisms to actually uncover, like scheduled tasks, registry modifications, things like that are pretty well known and have been used for a long time. WMI is the one that gets a little more interesting. So we're going to walk through both the attack and defense using this tactic. So to kick things off, we wanted to just simulate an attacker breaking into an organization. So we decided the best way to do that is a phishing document. Over here, we have our trusty little DocuSign document that this user has just clicked on. Now, throughout this demo, we've kind of highlighted all of the different techniques and tactics that will be used. And those are each kind of detection points that you should be picking up on within your security operations center as these attacks are unfolding. So, hopefully you'd be catching the attacker at this point before they're able to, actually gain that persistence and spread laterally and perform other actions on the host. And so along this same line, while we're talking about Office documents, I did want to touch on one other persistence technique. And this one's actually pretty popular, pretty good way to leverage this kind of ongoing persistence within an organization. Doesn't really have much to do with WMI, but it is one I wanted to touch on since we were covering phishing. So especially organizations where you use these centralized templates where people are always kind of pulling, you know, they're using kind of the same templates that are pulled from a share or something like that. This is a great way for an attacker to establish persistence by basically modifying these templates and injecting macros directly into them. The real added benefit of this is if it's a trusted template, you're not going to get that prompt to even run the macro. So a lot of people won't even know that their document has been modified. So not only are you infecting the users that are creating these documents, you're infecting whoever else you're sending these documents out to. So really, really unique persistence mechanism. So next we wanted to do is just show some initial post exploitation. So at this point, the users clicked on this document and now the attacker has a shell on their system. As you can see, we're using a Cobalt Strike for this demo. Now, one of the things we always get a kick out of that I just wanted to show here was people trying to figure out what security tools are in place on the host. By this point, we should have already detected them through multiple other TIDs, but it is something we see more and more commonly now that there are aggressor scripts that basically include these checks right out of the box. So, you know, that security software discovery right there. Credential access is actually a tactic, but I figured we'd cover it here because the attacker will usually want to gain access to credentials or otherwise find a way to elevate their permissions. So the next thing we have to do in order to establish persistence using WMI is we do need administrative access to this host. So what they're going to do is go ahead and run the UAC token duplication exploit via Cobalt Strike to basically gain that the administrative level access to this host. And so once they do that, we can see over here, they've elevated their permissions. So now we get the little lightning bolts. It's always fun if you're using Cobalt Strike to see that you actually have an admin shell on a host. So once they get that, now they can actually proceed with establishing this persistence. So over here, we're actually going to use an aggressor script to do this. Now, the aggressor scripts are awesome. Basically, these automate common tasks that are performed during post-exploitation. So over here in the red team set of scripts, you can see we've loaded all of the persistence mechanisms in here. And you can see we have various options available to us. And the neat thing about this is you actually don't really need to really know too much to run these, which kind of makes it a little dangerous in a way as well. But the ones we're going to focus on are these two here, the WMI Event Persistence using PowerShell and WMI Event Persistence using WMIC. Now, both of these will often use PowerShell. It just changes depending on the parent process that will be executing the attacks. Of course, if you use the WMIC option, you can do download and execute. You can do all sorts of other fun things that could bypass PowerShell logging detections. But we're going to focus on the PowerShell one because this is the one we see most commonly in the incidents that we've been investigating lately. So over here, once you click on that aggressor script, it basically gives you this nice little pop-up here that allows you to plug in all of your variables. So we're going to name our event consumer. Of course, we named it legit event consumer, so they'll think it's legit. The custom event query is actually what's going to set up when this job is going to run. It's kind of tricky to see here, but we do have a video kind of covering this that shows more of what that query looks like. But in short, what we're doing is making sure the system has been turned on for at least 4 minutes. And between a 4 and 5 minute window, this job will execute. And at that time, it's going to run that last line, which is our encoded PowerShell string. So we'll go ahead and click create. And now we should get some feedback showing that within our command line event consumer, which is what we're looking at here, it actually shows that our encoded PowerShell will execute when this kicks off. So to test this, one of the things we just decided to do is force a restart on this computer. Now, this is risky because as soon as we do this, we're going to lose access to both of our established shells here. So probably not something an attacker would do. but it is something we just wanted to do to highlight kind of how, and make sure the persistence comes back for this demo. And so once we hit reboot, we get our new shell. And as you can see, this one's actually system privileges. So we now have even higher access into the host, and our two previous shells are dead, but now we have that persistent access into this host and we can continue with post exploitation. But instead of going further down that kind of rabbit hole, if you will, we wanted to touch on how you can detect this. And not just, you know, one or two ways. We wanted to cover 7 different ways to actually detect this activity. And 6 of those ways you can do completely for free. So no commercial products or anything of that nature are required.
Great. Before we get into the detection, I did have one quick question for you. During that whole process, about how long did that take you to put the demo together? And then just a maybe slight speculation question, how long do you really expect that, you know, your typical reasonably competent attacker is going to take for that process of getting that system level access?
Yeah, I mean, honestly, it's very quick, especially with the aggressor scripts. It's pretty much point and click in order to do this. In the video we put together of this, we went through kind of a different way where we actually had to load our own PowerShell in order to do the post exploitation. So really it depends on the target and how well hardened they are. You know, if you're going into an environment that doesn't do application whitelisting, they don't have EDR or even AV, it's trivial to gain that initial access and then especially elevate permissions and establish persistence in multiple ways. And, you know, with the malware that we're seeing lately, most of the time they're doing this just automatically. You know, as Blake was saying, this is just included within a lot of post exploitation. We've seen this with large botnets as well, using Eternal Blue to spread and immediately establishing persistence with WMI. So it's something that can be done very fast. And the tools now, you know, such as Cobalt Strike, and especially some of the deep web kind of more scary C2s, they make this very easy for people to do. So it can be done very quickly and easily.
Got it. And I think that's definitely something important for everybody to consider, is that, yeah, we are talking about fairly commoditized capabilities, but as you mentioned, let's talk about how we're going to find those. We do have 7 methods, and as you said, the majority of these are going to be free methods. We had a couple of questions on OSQuery. We're going to touch on that here. So we'll go ahead and shift into our first method of doing that detection, and I will hand that back to you, Shane, to show us that with PowerShell logging.
There we go. So with PowerShell script block logging, you're going to get the command that gets executed. I believe it will decode it too, if I'm not mistaken. If it's encoded, if not, you can just run that and reverse that base 64. Sometimes it's as straightforward as that. But like I was saying, it's very important to understand what's executing within your environment. Me being a previous system administrator, whenever I would run my commands in my environment, I was super lazy. So I would never go through and encode commands. So you won't see a lot of system administrators doing this. So this is why just understanding how your system administrators operate within your environment. I know some do. And it can be a challenge sometimes trying to figure out if you're not 100% sure what's going on. But like I said, if you don't have encoded commands operating within your environment, it's very easy. But if you do, just decoding that base 64 is pretty easy. And you can just do that by, depending on what kind of sim you're using or whatever you're using to correlate these events, you can extract those command lines and just do simple string searches for things like encoded command. And we'll have another, we'll touch on AMSI a little bit later too, and it'll show the actual decoded command that'll show, in addition to the encoded command, what you can also search for within your environment. And a lot of these PowerShell encoded commands, a lot of these are default, depending on which attack framework you're using. So some of these do change, some of these don't. It just depends on how much effort your attacker wants to kind of put into this. So do keep that in mind. There are ways to change some of these default values too. So that's with the PowerShell script block logging. The next one we're going to talk about is Sysmon. Oh, but I think Blake did want to add something here too. I'm sorry. Did you want to mention something about PowerShell, Blake?
Yeah, so speaking more broadly than just persistence, PowerShell is very incredibly common. So currently we have 65 examples linked into attack for groups and software that have been known to use it. And that's because it's so incredibly versatile. You can use it for a bunch of different things. And like you said earlier, if you're not collecting and looking at the right data, you're not going to see that specific details. So just to speak on a couple of specifics, adversaries use it both to interact with systems once they already have access through existing tools, and they've also been developing fully featured backdoors completely in PowerShell.
Another neat thing about why you would want Sysmon. I think we went one slide too far.
My mistake on that.
There we go. So
my bad.
Yep.
Keeps messing up on me. The animations, you got me with them.
So you can see this event is from Sysmon. Looks very similar. If you're not familiar with script block logging, I'm sure a lot of you are, but if you are not, some of the differences between this, it looks very similar to what you would be seeing with the script block logging, but the added advantage of using Sysmon is that you kind of also get the command, like the parent command line, as well as the image or the binary that's launching this. So depending on how much automation you have on your SIM or whatever you're forwarding these events to, you can do things like automate some of that lookup to check for what parent process is launching this. So in the event that word spawning PowerShell, these are some of the easy things you can look for. It's not always as straightforward as that, but in this instance, we have WMI spawning an encoded PowerShell command. Again, it's not something that happens quite frequently. So in addition to just those command line checks, you can utilize parent process as well to help kind of zero in on some of that activity. And in addition to that, what Sysmon will also give you is it should be given an event ID of 3 as well, which is on the next slide. That will give some of the network beaconing activity, if you will, of the destination IP that was generated from this process, which is, again, super useful if you're trying to correlate all of this activity as to what happened. And there is a little bit of configuration that you have to deploy for Sysmon, and that's why it can be overwhelming for some. But if you, there are a lot of default Sysmon configurations out there. We posted one in the blog we put out last week that Brian had linked to in the chat. But also, I'm sure most of you are aware of Swift on security. It's pretty straightforward. Depending on your environment, you will have to tune it a little bit, but for the most part, it's very simple to deploy. Highly recommend pushing that through your environment if you don't have something else already in your environment. Free and cheap, or I guess cheap being labor hours that have to go into it. So. Yeah,
definitely. I'll touch on this one real quick because having more of a DFIR kind of perspective on things, a lot of times we're coming in after the fact, and a lot of our methods we're going to talk about here today that we've all pulled together are really good for time of execution, time of maliciousness detection. And I like Sysinternals because it's one that we can actually use after the fact. The Autoruns module, it's kind of one of these classic computer forensic, digital forensic tools. It's going to look in a lot of different places for anything that's slated to run automatically. And you can see here, there's a number of tabs that are in the tool, again, a free tool, but you can run this against a disk image or even a live system, and it's going to give you an idea of what the processes are that are attached to those various mechanisms of automatic execution. So whether they install a service or whether they manipulate some of those template files with the Office documents, you're going to get a pretty good idea of what's been implemented there. So from a forensic point of view, kind of adds a good capability over to the detection capability, because it's always kind of amusing to me when people say, man, if we could only go back in time and do all these great things, I could have detected this when it happened. It's great if you got the forethought to be able to put it in place, but sometimes after the fact is going to rule the world for you. But there are a number of others. Let's talk PowerShell here. And Greg, I know you've got this one. Let's talk a little bit about pulling this off of with the Get-WmiObject method.
Yeah, so honestly, one of my favorite ways to actually detect and both respond to this persistence mechanism is just simply using PowerShell itself. This is something that you can do both locally on the system, or you can do this remotely across your enterprise. This is something great for, just understanding what these baseline configurations look like, and then looking for changes to that over time. So Get-WmiObject is a great function for just simply looking at what is in, right now what we're looking at is the command line event consumer. And so, simply querying this across your enterprise, you'll quickly find out if there's someone, doing something like we've done here with this giant chunk of encoded PowerShell. Obviously something that's shouldn't be on this host, but it's a really quick and easy way to detect this activity at scale.
And just to interject too, I kind of mentioned on, I guess previously about that encoded command. These are just some statistics we kind of see across all the clients we monitor as well, because there are a lot that do use encoded commands occasionally. But around 80% of the time, if that encoded command is shortened, it's almost always, like I said, it's 80% of the time it is malicious. So that's another easy win for you if you're just trying to add additional detection methodology within your environment, which it's kind of neat.
Definitely. And that's one of those things where, this is a pretty straightforward kind of basic encoded command that we're looking at here. These newer attack frameworks and exploit kits and things like that make it very easy for someone to create these really complex and chunked out encoded commands that make it much harder to decode. And so I'll actually touch on a couple ways you can pull the actual original script out of some of those in a couple slides as well. But probably my favorite part of this on this slide is actually looking at how we can actually clean up after this activity. So using PowerShell makes this really easy. If you say, see this within your environment, you can actually query just based on the name or other different variables. And then you can pass that to remove WMIObject, as you can see kind of at the bottom there, and that'll actually remove this from the system that you're on. So, likely there will be other persistence mechanisms at play as well as WMI, but, to clean up from just the WMI persistence, this is a great way to do that. And this works with event filters, command line consumers, and kind of everything that relates to WMI.
Excellent. Kind of gives you that that 1-2 punch capability.
Exactly. And so we've had a lot of great questions around OSQuery, which is awesome. I'm glad to see people leveraging this, because this is such a powerful tool that you can run, both locally, as we're looking at here. This is just run on a local system, but you can also run this across your enterprise. If you have these agents deployed, you can query these and then start building those baselines and understand, how you can look at these over time and see if there are changes. And so OSQuery, it actually has 5 different WMI queries built in directly. So it makes it really quick and easy to find these malicious WMI objects that we're highlighting here. And this is also something that we've baked into the Carbon Black agents. So, if you're using Carbon Black, you can actually leverage OS queries directly through that interface as well. Now, AMSI is something we've been focused on a lot. One of my teammates, Jimmy, he's like a ninja with writing rules around AMSI because there's so much useful data that AMSI collects. Now, the big thing we get from red teamers and pen testers alike is that, hey, I can unhook AMSI, I can disable it, I can do all these kind of things. It's like, yeah, but that's a detection in of itself, because when AMSI is unhooked, that leaves a signature, so we detect on that specifically. In addition to that, what we're looking at here is just kind of the whole process that this one attack goes through. And you can see we get to the raw source code of this encoded string very quickly and easily. Now, what we didn't highlight here is actually the next phase. If someone's shoveling a reverse shell out or something like that, you'll actually get the actual shell code. So it gives you kind of all of those details you would need to really understand what's happening here. And the other added benefit is we can pick up on pivoting activity, both from the originating host and the host that's targeted with the pivoting. And right here, we're actually using invoke WMI method to pivot to a separate server named mail. So WMI is a great pen tester tool.
Absolutely, it's definitely helps to identify benign from malicious. Then that's actually a question that was mentioned, is that apparently somebody had noted that Office is now doing encoded PowerShell strings, which is generating a lot of false positives. And I would just take that note and kind of turn that around to say, with a lot of the instrumentation that we are talking about here, just getting the artifacts of that happening, it's going to generate some false positives, but hopefully it's going to give you a large enough corpus of observations that you can kind of narrow down the ones that belong and that are typical and find those outliers. I'm not going to say that that's a push button solution, but that is why we're all employed after all. It's going to be something we've got to maintain kind of awareness of normal versus abnormal in the environment. Well, the last one we got up here. Oh, I'm sorry, go ahead.
I was going to say in two, because we kind of touched on the script logging in Sysmon earlier, and they were kind of just straightforward focus on the encoded command. Back one slide on the AMSI, it does decode what is happening in that base 64. And you can kind of see what I was kind of referring to. If somebody doesn't use that encoded command within their environment, you can kind of pick out some of those strings as well within your environment to trigger alerts on as well. And in the event that, you know, somebody's not just relying on encoded command in your environment. So something else, just it's down there at the bottom where it's kind of highlighted. It says credit to manifestation.
Right.
Oh yeah.
So
and one of the neat things, yeah, like while we're on here, one of the real cool things is you can look at the app name. So right away we can see app name SVC host. So that's an indicator right there that, okay, this is not PowerShell executing these PowerShell commands. Oftentimes we'll see JScript, WScript, things like that, which can be great indicators to leverage. And AMSI does a really good job of pulling all of this data. Another real key indicator is this content length. So, you know, down here where this script is fully taken apart, we can see there's over 3,000 characters within this string. And so, you know, like tying all this together gives you a lot to kind of go off of in terms of building rules, you know, whether it's within your EDR, within your SIM, kind of what your organization has at its disposal to collect this data and parse across it.
Sure. And there's actually two semi-related questions in the question bank here. I figured this is a good time. For those not familiar with AMSI, where would these logs be pulled from? Can you just elaborate just a little bit on where those would be seen?
Yeah, so this is something that's related to Microsoft's Defender side of things. So it's basically, you can tie into this. There's a couple ways. Matt Graber, who's actually a manifestation down here, if you look up his name and look up enable AMSI, he has a great GitHub link that basically covers, here's a couple quick PowerShell one-liners that you can run to basically enable AMSI on the host. And that will create a event log that you can collect with your SIM. Now, a lot of us, you know, that work for antivirus vendors and EDR companies, we're looking at this kind of in a different way. We're hooking this programmatically and parsing this data with our agents. But basically, you know, even if you don't have a SIM, you can still enable this across your organization and do kind of that hunting, because it'll still generate those raw event logs.
Perfect. And that actually dovetails to a question that Alexander had asked as well about using SIM systems with some of these capabilities. And I would say that with some of the forensic capabilities, you know, like you said, running the tool on a schedule could be possible, but I would generally say that some of these other more long-term kind of continuous collection solutions are probably better suited for that type of environment because they can feed into that SIM. There's one other thing we're going to talk about here in detection, and this is going to be the one that kind of goes into the commercial space. We like to give everybody a mix between the commercial and the free solutions, but give us an idea of some of the stuff that you can see with EDR, given your perspective, Greg.
Yeah, so EDR kind of makes this pretty easy. Like all of the attacks that we covered in this demonstration, and also a lot of the other persistence mechanisms that were covered earlier in the slides, basically we already have rules created around those. We do a lot of testing within my team specifically around executing these attacks, looking at all the different ways that attackers can kind of pull off these sort of attacks and what that telemetry looks like. And so, everything we talked about in terms of WMI, you can actually find within Carbon Black today. And so, it makes it pretty easy when you're hunting for this, because you can look for, parent process WMIC, child process is PowerShell, just kind of some of those queries that help you do proactive hunting for this. We're also looking at all sorts of different ways that this persistence can be leveraged outside of just PowerShell, which we covered today. So you kind of wanted to touch on all of those different ways that this persistence can be established. And so that's one of those things where, if you enable the advanced threats feeds within Carbon Black, these attacks will be picked up automatically.
Very cool. And a question that came in that kind of feeds back to that. Question on whether Carbon Black is currently inspecting AMSI events, our previous detection method.
Yeah, so that's something, it's in development right now. We've been playing around with it, and we actually, my team has actually been working on creating rules specifically for AMSI events. And so that's something we hope to have out within the next few months, but don't quote me on that.
Got it. Well, that's good to know. Definitely cool to see the kind of expansion of coverage in some of these different, more newly developing areas. That does bring us pretty close toward the end. We've answered a bunch of questions already, and they've been great. We do have about 9 or so minutes left here, and I want to be respectful of everybody's time. So if you've got questions, please do put those in specifically the Q&A box. That helps us to kind of divvy those up a little bit, make sure we're getting coverage on them. One of the questions that came in, Ken had asked about how any of these detection methods for persistence change when we move into EC2. Or to any other cloud provider. EC2 is the one example typed. But does anybody want to talk a little bit about that? I mean, outside of treating every cloud-based instance as an endpoint, which it is, are there any other things that you've seen with regard to persisting in a container or maybe in an AMI instance or something along those lines?
It's a good question. It's one of those I think we're going to see more and more continuing to kind of grow over time, just as more and more companies are shifting to using cloud infrastructure. I mean, at the same time, a lot of these are still going to be base OSs, but when you get into Docker and Kubernetes and things like that, can definitely get creative there. I don't know if anyone else has a better answer.
Yeah, I was just going to suggest it's going to get, I guess the more migration towards that environment, just the amount of infrastructure that's going to have to go forth and the effort put in is going to be quite difficult. So, but it should still be very similar to what you're doing locally, but just ensuring that the logs that you're forwarding are secure and how you're forwarding them all is quite difficult, I will say.
Yeah, I would actually say that I think the fact that we had 7 different means of detecting this shows that a varied approach is going to be really important. We had a number of questions that were along the lines of which one of these is best or what should I prioritize, and you could really come up with an arbitrary number of answers for that, right? Because it depends on so many factors. So I would just say having a wide variety of mechanisms for detection and visibility is going to maximize your chances of seeing both the well-known, long-established mechanisms like we talked about, as well as some of the more newer, novel ones, hopefully. And obviously, this is a very rapidly evolving field as well. We're going to see a lot of new detection and response capabilities that are going to come along, I'm sure, that'll help us to do better with whatever the technology of tomorrow might be. Let's see, I'm looking through some of the other questions. I don't know if anybody had grabbed any of those. There were a couple of CB specific questions, and rather than us get into some of the weeds on that, because that can be pretty widely varied, you know, I would say that the assist teams and basically your support folks that you work with on your normal CB instances are going to be able to have access to this webcast as well. They'd be able to best trace some of the things we're talking about to your specific environment. And I would generally say that of any of the various EDR platforms you might be using as well. Let's see, other questions in here. We answered that one. Do we have any other examples of Office templates being used for persistence? You know, that's actually a good question, Blake. I'd like to kind of turn back to you. Do you have any specific threat actors that you know of that we could be, you know, have folks look up to see that are using those templates in particular? Sorry to put you on the spot. I thought it was a pretty good one to hit.
Yeah, let me pull up ATT&CK real quick.
I'll tell you what, you know, we can actually do. We can actually take the result on this, because I know you'll generate the URL that shows that. We'll actually include that in the email that everybody will get as well. So if you don't grab it right now, I think that's fine, but we'll make sure everybody gets that information. And actually, I just got a note in here that Malcab is one in particular that used an Excel startup item. So just MAILCAB would be one to potentially look up on that as well. Good question, trying to find out the real world examples of some of those. And in terms of the link that we talked about, some GitHub PowerShell stuff previously, we'll collect that and get that into the email as well. Those are really good resources to send after the fact. Let's see. I will take a look at some of these other questions that to see if we can follow up on them afterward as well. Does anybody else see another one in there that's of interest you want to jump on?
Yeah, somebody had asked about what is the best method for automated coverage testing for persistence in attack. So there's a whole market segment out there for breach automation testing. So you might look at something like that, but there are a lot of publicly available open source tools like Red Canary's Atomic Red Team and the MITRE Caldera framework. That have several persistence mechanisms built in that you can use to do automated testing with.
Excellent. And I see there's a bunch of resources being posted into the chat as well. So some of the questions on some of the links, the GitHub question in particular has a link there. So be sure to check that one out before you jump out today. I saw another question come in here. All right, we're coming up fairly close to the end, and some of these are pretty in-depth here that I don't know that we'll be able to really do justice to on a webinar, but just kind of open this back up for the last few minutes here. Anything that you guys would like to add on, kind of closing thoughts and comments, specifically on persistence, or maybe looking forward to some of the other things that we've got coming down the line? That was easy. No worries. Well, what we're going to take a look at now, we'll go through the questions that we didn't get a chance to answer, see if there are any of those that are either something we can feed into some of our future webinar series that we're already planning. We will send you an email. You'll get that in about a day or so after we go through post-processing on the video. It's going to include not only a link to the video, it's also going to include a couple of additional resources. We've got one cool resource we're going to be sending to you, which is going to be a little bit more detail on that attack sequence that Greg had modeled for us during the presentation today. And it's also going to include the results of the poll. So we polled you about which technique you'd like us to, or tactic you'd like us to look at next. We're going to share one of those that we'll use as our next one and kind of give you some foreshadowing into the future portions of the webinar series. And you know, anything else that you might have, feel free to reach out to us on Twitter. The posts that I know all of our organizations respectively have been putting out in recent posts have our handles on, so we will see them. We'll be able to answer those for you. Definitely get you some further information if you can think of it. That all being said, that's what we've got for you today. I appreciate your time today. We had a really good showing here, and I appreciate you joining us for a portion of your day, whatever time of day that might be. And I look forward to having you back again. We'll be certainly keeping in touch with you on various media, and look forward to having you and other of your colleagues join us back in the future. So that all being said, have a great rest of your day, everybody, and we look forward to future events. Cheers, and have a good one. Thanks, guys, for your time as well.
Yep, thank you.
Thank you.
Thank you.
All right, I think we are clear. Is that correct, Brian?
I'm not sure about that. No, there's still some people in there.